Okay, it's Math 8, Unit 5, Lesson 16, Finding Cone Dimensions. Alright, so first of all, you start off with a little number talk today about thirds. To find each quotient, decide what value, if any, would make it true. And so this is something you can talk about in your class today for the value or the number you could put in terms of the H, or the R value, or the A or the B value to make this work out. And so that's something for you guys to do in class together and talk that through. If you need to press pause and do that, you certainly can do that. And I'm going to move on to section number 2. Okay, number 2, an unknown radius. The volume of a cone with radius r is given by the formula volume equals 1/3 pi r squared h. The volume of this cone with height 3 units and radius r is 64 pi cubic units. This statement is true. So 64 pi equals this whole stuff there. What does the radius of this cone have to be? Again, we did a problem like this back in lesson 14. We did with cylinders. Same idea. Now we're solving for some unknown dimension of the cone there. So the way we did this last time, if you recall, is we set that equal to each other. We said, well, if I have 64 pi on this side, I'm going to have that equal to 1/3 times pi times the radius squared times 3. Now in this case, 1/3 times 3 actually equals 1, doesn't it? So what I really have now is 64 pi equals pi times the radius squared. So I need to think to myself, what number squared can get me to 64? And in my case here, I recognize that 8 squared equals 64. So 8 is going to be the value of my radius. Okay? That's the radius is going to be, because 8 times 8 is 64. So 64 is 8 times 8. So my radius is going to be 8. Alright. Same idea as we did with the cylinder. Now what we have on the next page, activity number 3, are cones with unknown dimensions, just like we have the cylinder, and we have a chart this time again. Same idea, and we have to fill this out to figure out what are the missing links here. Okay, so we have the radius. The diameter is going to be times 2, right? So 4 times 2 is going to be 8. If I'm going to do this one times 2, 1/3 times 2 is 2/3. Nothing to do here. This way, it's going to be divided by 2. So 20 divided by 2 is 10, and nothing else that way. So I've taken care of what I can take care of so far. Alright, let's move this way. Area of the base. Base is going to be pi r squared, right? That's area of the base, no problem. So the radius is 4. So we have pi times 4 squared, which becomes 16 pi. Alright. Now the height is 3, and we want to find the volume. Remember, all this will be multiplied every time times 1/3, times 1/3, times 1/3, times 1/3. Times 1/3, times 1/3, right? I'm going to always do that. So 16 pi times 3 times 1/3 is going to equal my volume. This is going to cancel out to 1, so I'm left with 16 pi. Here, I'm going to take the pi times the radius 1/3 squared. 1/3 squared is 1/3 times 1/3, which is 1/9 pi. So 1/9 pi times 6 times 1/3 is going to be equal to my volume. In this case here, I can reduce 3 goes into 6 2 times, and so I have 1 times 2 times 1 across the top, which is 2, and then 9 times 1, which is 9, so I end up with 2/9 pi. Over here, I'll go ahead and multiply this out to get the volume. The volume is going to be all this multiplied together. Alright, and so a couple ways. I could do 36 and 4. 4 goes into 36 9 times. So I end up with 9 and a 3 there, but 9 goes into, or 3 goes into 9 3 times. So I end up with 3 times 1 times 1, which is 3. And I have a 1 on the bottom, so I end up with just 3 pi. Now, I gotta go back on this guy. 36 pi, that's the radius squared. So what number times what gets me 36? That'll be 6 times 6, so the radius is gonna be 6. And when I multiply by 2, I end up with 12. All right, coming this way. Here's our pi times the radius squared. That's going to be 100 pi times some number, the height, whatever that's going to be, times 1/3 equals 200 pi. All right, so this one here, you can think of it like this. I need to get 100 times a number, or 100 times 1/3 times a number to equal 200. That's the idea. Forget the pi's for now. They're going to cancel each other out, right? So this becomes 100 over 3x equals 200. And to get the x by itself, I'll multiply by the reciprocal. All right, cancel, cancel. So I have x over here equals 200 over 100. That's going to reduce down to 2, right? And so what I have, 2 times 3 is 6. So what's the height I'm looking for right here? You would say it's going to be 6. And you can look there and see 6 divided by 3 is 2. 2 times 100 is going to be 200. So that works out just fine. All right, coming back this way, we know that we have, well, I have this. I'm looking for the area of the base. All right, I'm missing something there. So as I write this as an equation, I know that my volume is 64 pi, and that equals pi times the radius squared times the height times the 1/3. All right, so 12 divided by times 1/3 is 4. This becomes 64 pi. 64 pi. Radius squared times 4 there. Okay, and then divide both sides by 4. So we end up with 16 equals the radius squared. So what number times itself gets you to 16? That's going to be 4. So the radius is going to be equal 4. So that puts a 4 here, which I could think about that as being doubled, which I got to find that one, which is pi times the radius squared, which is 16 pi. All right, our last one here, we have to have a number that you multiply by 3 and 1/3 to get 3.14. Well, this whole thing there is equal to 1. Notice that there's, again, no pi, right? This has to have a pi in it because that's part of the formula. So pi times what number can get you 3.14? That'd just be plain old 1. So we're going to have an area of the base of 1 pi, which makes our radius 1, which makes our diameter twice that, which is 2. Okay, so a lot of computation there to do that. I'm sure we'll see more of it later on. And that's it for that part right there. Let's take a look at the next page. I'm going to go ahead and skip the Are You Ready for More for now. Okay, and we're going to go to our last one here, the popcorn deals. Popcorn deal, what a great deal. We have popcorn in a cone and popcorn in a cylinder container. And we have to decide which container has the best volume. Use 3.14 as an approximation for pi. So on this side, we would say that the volume of what fits in here, we have 1/3 times 3.14 times, now be careful here, we have to do the radius squared. The radius is half of what's here, that's 12, so that's going to be 6, right? So 36 is our radius squared, and our height is going to be 19. So when you multiply all of this out, we end up with a pretty crazy number. You end up with 715.92. Okay, I'm just doing some shortcut here because this is review stuff. So that's how much the volume of popcorn that'll fit in there. On this side over here, it's the same idea, right? Except I'm going to take pi, 3.14, multiply by the radius squared, in which case is half of that, which is 4. So that's going to be 16. 4 squared is 16, times the height, which is 15. And I multiply this out, I'd have 753.60. All right, and that's how much is in that container. This would be like centimeters cubed, centimeters cubed. So you know you get more in here than this one, but you have to decide, look at the price to decide which one is a better deal. Now, Knowing what I know so far, I'm going to say that this one already is a better deal because one, I get more, and two, I can tell it's less. How do I know for certain? Well, I could divide the centimeters cubed by the actual price, 6.75, and I could divide this one by the actual price, 6.25, to see what the volume is per $1. In this case here, I get 106.06 centimeters cubed popcorn for every $1. And over here I get 120 point, I think I wrote down 576 centimeters cubed. That's my amount of popcorn for every $1. So I get more popcorn over here. So my winner is going to be the cylinder there. I get more popcorn for less money. It is a better value. All right. So let's take a look at your notes, your summary for the day before we move on to our homework. It says, all right, we have our formula for the volume of a cylinder, 1/3 pi r squared. And again, if we know the radius and height, we can find the volume. If we know the volume and one other dimension, we can find the other dimension. So just like we do a cylinder, but now playing with cones. So pause there and work on your homework, and let's come back together and check it in just a moment. All right, so here we go, homework time. The volume of a cylinder is 175 pi. What is the volume of a cone that has the same base area and same base height? So a cone is 1/3 of the volume of the cylinder, 175 pi. So you have 175 pi, 175 over 3 times pi. We could write this out as 175 over 3 times 3.14. And if you do the math on that, you end up with a crazy old number. Not really. You end up with, I wrote in my notes here, I don't write 183. I don't know. Let's get out the calculator because my notes are just not making the sense they should. So, sorry. So if I do 175 and I divide that by 3, I end up with about 58.3 repeating, times 3.14 times 3.14, and that gets me approximately 183.1 and round up to 17, something like that for the volume of the cone if I'm not using pi. If I'm using pi, I could leave it like that, okay? But if I'm not, if I want to use 3.14 for the value of pi, I get that. A cone has a volume 12 pi cubic inches. Its height is 4. What's the radius? So we know the volume is 12 pi, and to get that, it'll be 1/3 pi times the radius squared times the height, which is 4 in this case here, right? So 12 1/3 pi r squared 4. All right, I'm going to go ahead, I'm going to multiply both sides by 3. Okay, so multiply by 3 times 3, so that goes away. 3 times 12 is 36 pi equals r, I'll do pi squared, or pi r squared times 4. Let's divide both sides by 4 pi. And 36 pi divided by 4 pi is 9. So 9 equals r squared. And so what number times itself gets you to 9? That'll be 3. So our radius is going to be equal to 3 for number 2. Number 3. A cone has a volume of 3 pi. If the cone's radius is 1, what is the height? Okay, so we're just going to plug some things in here. If the volume is 3 pi, we say that 1/3 pi times the radius, which is 1 squared times h. Finding the height. So if I multiply this by 3 over there, I end up with 9 pi equals pi times h. So what's h going to be? It's the missing value right there. H is going to be equal to 9. Remember, letter A. If the cone's radius is 2, Alright, so we have 3 pi equals 1/3 pi. And then because it's 2, that's going to be 4 times the height. Again, I multiply this by over here to make that 9 pi. So 9 pi equals 4 pi h. Divide both sides by 4 pi. And h is equal to 9/4 for B. Kind of weird, but it does work. For C, same idea. 3 pi equals 1/3 pi times the radius, which is 5 squared times the height. Okay, and 5 squared is 25. So I can multiply this by 3 again, so you have 9 over here. 9 pi equals 25 pi h. And so you divide by 25 pi, and what you're left with for h is 9/25. D, if the cone's radius is 1/2, what's the height? Again, same idea. Okay, we have 3 and pi equals 1/3 pi and 1/2 squared h. So 1/2 squared h is 1/4. So we actually have 1/3 and 1/4, which is 1/12. Multiply this by 12, that gets you 36 equals h for D. And the last one, if the cone's height is radius r, what is the height? And that's going to be looking like this. You're going to have 3 pi equals 1/3 pi r squared h. And so we know that we're going to leave the height over there. That becomes 3 times 3 is 9. So you have 9 pi. The pi's are going to cancel. So it'll be 9 divided by whatever r squared is going to be. So 9/r squared. Alright. 3 people are playing near the water. Person A stands on the dock. Person B starts at the top of a zip pole and zip lines in the water. And person C climbs out of the water up the zip line pole. Match the people of the graphs that they represent. Alright. So looking at our little chart here, right here. Person A, it says stands in the dock. So they just stand there and they never move. So that to me looks like this guy right there. That looks like person A. Person B, it said, starts at the top of a pole and zip lines into the water. So they start on top of a pole and they go, looks like, into the water, and then they must probably come out at some point. So that looks like a B to me. And person C, it says climbs out of the water and up the zip line pole. So that person's coming up. That looks like C to me. This water level is probably at 0, and that's the person going in, person going out, and hanging out on the dock. Alright, and number 5, my last one for the evening here before I call it a day and do some more tomorrow morning. A room is 15 feet tall. An architect wants to include a window that is 6 feet tall. The distance between the floor and the bottom of the window is b feet. The distance between the ceiling and the top of the window is a feet. The relationship can be described by the equation a equals 15 minus b plus 6. Alright, let's draw a quick sketch here. I like to draw pictures if I can. Not because they're good pictures, but because it helps me see stuff. Alright, so they want to put a window in a wall. And the window is going to be 6 feet tall. So the length here is 6. Now the distance between the floor and the bottom of the window, so here to here, is B, and ceiling to the top of the window, here to here, is A. Alright, the whole thing combined has a combined height of 15. So that's our picture there. A, this value here, is equal to the whole thing minus the sum of this. So 15 minus these combined gives you A. That is true. So which variable is independent based on the equation given? So based on what's in here, what is independent? Well, because we're trying to solve for A, what is independent is going to be B, because whatever we put in B will determine the value of A. So A's value depends on what we put into B. So B is going to be independent based upon the equation. If the architect wants B to be 3, what does this mean? Well, if he wants the height from here to be 3, what it means is that the bottom of the window needs to be 3 feet above the floor. That's what it means. So then what value of A would work with that given value? Well, let's figure that out. So if A is going to work out, then you end up with 15 minus 3 plus 6, which is 9. So 15 minus 9, and 15 minus 9 is going to be 6. So what value of A would work? 6 would work. The customer wants the window to have 5 feet of space above it. Okay, that's going to be the A value. Is the customer describing A or B? Well, we just said that's the space above it is A. What is the value of the other variable? All right, we could solve it a couple ways. We could say that 5 is A equals 15 minus B plus 6. And we could solve it like this if we chose to, and this will work fine. To do this here, I want to distribute the negative all the way through. It helps me out a little bit by doing it like that. 5 is going to be equal to 15 minus B minus 6. Now, I'm going to just do some shuffling around, okay? I'm going to go ahead and what I'm going to do just to make it nice, I'm going to add B to this side. So I have 5 plus B equals 15 minus 6. 15 minus 6 is equal to 9. 5 plus B. And now I'm going to subtract 5 and subtract 5 so that B equals 4. And that works out just nice. I put the B over there first just so I can work with a positive B. Could you do it differently? You sure could. You could also save and you could change your equation around to say that B actually equals 15 minus the sum of A plus 6. It's the same idea as the formula before, except I put B there. And if I solved it this way, and A was equal to 5, I'd have 15 minus 5 plus 6, which is 11. 15 minus 11, which equals 4 for B. So this way works just as well as the other way. Depends on what you see and what makes sense to you. That's it. Have a great day, and we'll see you next time.